Today we're going to learn how to determine if an equation is linear or nonlinear. And the method we're going to learn is called first difference. Now let's recall what the general form of a linear equation looks like. It has y equals mx plus b, where b is again the point on which the line crosses the y-axis, and m is the slope. M can be determined in two different forms, using coordinates in the graph by looking at the change in y values over the change in x values, or by looking at the general rise over run of the line. So let's look at our first example and determine how we can use a first difference to determine if this equation is linear or nonlinear. Here I've created a table of values to determine what points are on this equation. So when I plug in x value, I have y equals to 0. When I plug in x value of 1, y is equal to 3. X is 2, y is 6, and then 9, and then 12 subsequently. So if I were to try to calculate the slope of my line, I would need the change in my y values over the change in the x if this equation is a line. So let's look at the change in x first. So I look at the change in x, I see that going from 0 to 1, it's an increase of 1. From going from 1 to 2, it's also an increase in 1. And it looks like the pattern continues. Recall that the change in x values tells me the run of this equation. If I were to look at the y values and see how they change over the points, I see that going from 0 to 3 is a plus 3. 3 to 6 is another addition of 3. And this pattern continues for the rest of my table. If I were to calculate the slope, if this was a line, I would just take my change in y value and divide by my change in x values. And so you can see that my slope would be equal to 3 over 1, which is 3. And because this slope is the same for each of these points, therefore I would hypothesize that this equation does indeed tell me a linear equation. Let's check on the graph. If I were to plot my points, I have 0, 0, 1, 3, 2, 6, 3, 9, and 4, 12. If I connect these points, I do indeed see that this is a linear line. So my hypothesis was correct. When I saw that the change in y values were the same and the change in x values were the same, this is called the first difference, because I am looking at the difference of each point and seeing if they're the same. If they're the same, they have the same slope between all the points, and therefore I would get a general line equation. Alright, let's apply this to two more examples to see if this method works. So here I have two equations, A and B, where the equation A is y equals 3x squared plus 2. I've created a table of value already, so let's look at the first difference in my x's and my y's. So here I see that my x is increasing by 1 each time. When I look at my change in y values, I have a plus 3, now I have a plus 9, plus 15, plus 21. So I see that these are not all the same. Even though my change in x is the same, my change in y is not the same. So I would think that this is a nonlinear equation. Let's look at the second example. If I look again at my change in x, I do see that it is increasing by 1. And when I look at the change in y, they are all increasing by 5. So these are all the same, and therefore this equation is linear.